The actual hands-on thing with working with students one-on-one, that's been a lot of fun. I really enjoy that type of stuff, and I really enjoy watching people throughout the weekend go from knowing next to nothing, and you could see as the weekend progressed, their skills progressed. It's been really rewarding to help them achieve that. So I taught pole maxing techniques on the MH19. I showed some of the dies that I've made over the years and kind of gave a basic rundown of making your own dies, learning how to identify profiles and then make the dies, and why I make them a certain way, and that whole technique and process. Not everything can be bead rolled or just shaped out. You have bead details, and the machine that is best capable to do that is a reciprocating machine. You don't always have the dies on hand to do that. So to be able to know how to make your own dies and continue to push your skills, that's what I came here to do.
So I'm Pete, as he said. I own Dexterous Engineering here in Salt Lake City. I also used to work here. So we're gonna go through, I kind of do more, I guess, unconventional sort of shapes with doing the pole max. I don't do typical like bead dies, if you will, like what we have here that come standard with your MH19. These are just standard bead dies for doing straight lines or just beads in a panel. Most of the dies that I use when I do like pole maxing or reciprocating machine techniques, I just make them out of 1/4-inch plate. The reason why I use 1/4-inch plate is because it gives me the ability to do tight radiuses for certain shapes, such as like when you run into dies, most standard dies like these, you can see they're big, they're bulky, and you run into clearance issues on certain shapes that you're trying to do sometimes. So I figured out a long time ago that 1/4-inch dies work great, and if you need to go wider, you can stack your pieces together and tack them or something like that if you need to go extra wide on something. And so you can kind of look at these. These dies are actually dies that I made a few years ago. They're for a 59 Plymouth, and they just sink together like that. The way that you make dies, I will go through and kind of give you a general gist. I'm not actually going to make the dies right now because that's quite the process, and we don't have the time for that. Normally, when we start out on finding a profile for making dies, you have some sort of guide, such as a needle gauge of some sort, or you can make a template piece with a piece of TIG rod and just lay it on the profile of the panel or something like that. So say like I wanted to just do the edge of this table with this little indent. I can take this, lay it down, lock it in, and now I have that profile. I can then transfer that profile to the material and create a male and female version of that. Then, once you have your actual cutout male and female version, you take it a step further. You want to have what's known as a lead in and lead out, which is pretty much just a fancy way of saying you want to have soft edges. Because you have two dies coming together and you're actually forming the material around those dies, and you don't want to have a bunch of chatter marks because that's more cleanup that you have to do at the end of the road. So the less you can reduce that cleanup while you're actually working, the better. So you want to have a soft lead in, soft lead out. On 1/4-inch, it can be pretty easy to get away with that stuff. You don't have to have too much of one. When you start getting into the thicker dies, that's when you want to have, or more advanced kind of shapes with different dies, that's when you want to have specific lead-ins and lead-outs on things.
When you cut the two pieces, do you make them fit perfectly together, or do you put a material thickness?
I do in certain areas. So for instance, these dies here, I have a soft round on the peak here, but I have it sharp in here because I know that the material is going to have somewhere to actually go in that section. And if you have a hard peak in the center of your highlight right there, you're going to run the risk of actually pinching it and thinning out that material, and you don't want that. Because if you keep running your material through your dies over and over and over again, you're just going to thin that out to the point to where it just splits apart at some point. Or like, usually it's in the 11th hour when you're doing all your metal finishing work and it splits, then you have to weld it back together and it's a whole thing. Ask me how I know. So yes, I do allow clearance in areas that I know I actually need for the dies, and that's kind of just based on trial and error and experience. A lot of times everything that I do is just kind of custom one-off. It's just regular mild steel dies. Most people use tool steel. I just use mild steel. I'm cheap and I just like getting stuff done. So right now we're gonna go through, I'm gonna hand out these two pieces. We'll just kind of go this way. Here, we'll go there and there. So those were a set of custom dies. This is actually a profile that I designed. It's not based off of anything. It's just something that I kind of thought up in my head and put in a break and did the first test pieces on the break itself and then made the dies to match what I had done on my test piece. So for these dies, you don't want to go straight into just flat piece of metal, especially when you have a set of dies that have this much of a deep of a draw, because you're just going to start chewing things up. It's going to shred the material. It's not going to be good. You need some sort of guidance as you're going along. And so for this, I already have a flange because I knew that I needed a flange on the piece, because on those, wherever they went, the top edge of it was getting grafted into a flat section of the panel. So I knew that I needed to have at least some sort of break. So I have a flange here, and in my dies, I have a relief for that flange to actually go into. I know that my highlight line on that piece needs to have some sort of guidance as well. And so I already did a break on that highlight line. Okay. Lock that in there. So right now we have 0.35 of a stroke, just so that we have enough clearance to get around everything. So now, it looks pretty mangled, looks pretty messed up, it's rough. But what we're doing right now is we're forming all this material on this back seam here and forcing it all down. And the rest of it is gonna, once we start tightening up the dies here, it's actually gonna start forming around and getting that actual disc shape in the center there. So, start increasing our stroke a little bit. you notice too, I'm not like doing my increments with each individual pass. I'm kind of going back and forth a few times with each one, just for the reason that there's a lot of different shape happening all at the same time on these dies. So, and the reason why I'm adjusting the stroke smaller and smaller and smaller is because I want that hit to be tighter and tighter and tighter until I go to my final pass, to where it's just pretty much just fluttering across the dies. Okay, so that's about as far as we'll take it now. But as you can see, it's not exactly a straight piece anymore. It's got a little bit of curvature. This is another reason why I left a flange on the top side and on the bottom side. So now, from here, we can manipulate it and actually get it to straighten back out. We can start bending it if we wanted to make it go the opposite way. We can stretch and we can shrink. We can do all sorts of things to actually manipulate this piece to the shape that we want it to be. So for right now, all I'm going to do is just kind of do a little stretch on it on the shrinker stretcher, just to bring it back a little bit and kind of clean up this bottom edge. So now we're gonna stretch on this top edge here, and you can see just doing light little kicks. And the further in you go at the dies, the less extreme it is. The more you work the edge, the more extreme of a shrinker stretch you're going to get. This aluminum is soft. Almost too soft. Okay, so we got that. We're gonna, let's stretch this. Let's see what it does. So this is the general idea of what you would be doing with those dies. Obviously, you can see on the far edges that it kind of flared out. That's kind of typical sometimes, depending on the shape that you're doing. So you just want to keep in mind that you want to always make your stuff larger than what you actually need. And so for me, that's my cutoff, that's my cutoff. And this is the good area that I can actually use for something. And you can be creative with your dies too. So we ended up using this as a trim piece to hold up a GT500 rear valence on the back end of a 56 F100. And so we actually had it contour and shape with the way that the valence actually went, and made square slots in it so the plastic could actually just snap right into it. So We're gonna move on to another set of dies that's a little bit easier to do. Typically when I set my dies up, I'll lock in the top die first, and then, or whichever is the male version of the die, I'll lock in first. And then the female I'll let float. And typically it's pretty simple with this machine. You just adjust it down until it locks in and can't move at all. And once it's in place, just go in and tighten it back up. Okay, so now we have quite a different shape than what we started out with. This is another reason why I like 1/4 inch dies, is because you can manipulate as you're running through. So say, wanted to actually start going the opposite direction. That one got a little mangled. But that's the kind of thing that you can do with the reciprocating mode on this machine, is you can get just, I don't know, creative with your ideas and just let your imagination go wild on different shapes.
Eat Watkins, everybody.